This is Algebra 2, Lesson 2-8, two-variable inequalities. Now we've done two-variable inequalities before in Algebra 1. We're only going to add a little bit more to this lesson toward the end. So this should be fairly simple for most of you. Once we review it, you should be coming back to it and you should be remembering what you did for this. A linear inequality is an inequality in two variables whose graph is a region of the coordinate plane bounded by a line, which means that replacing the equal sign with an inequality sign, and then you have to do some shading. The boundary is the line that separates the regions of a linear inequality. Half planes are the two sections that a linear inequality is separated into on a coordinate plane. And as you're using the shade on one side of your boundary line or the other side of your boundary line, which will divide your coordinate plane into half planes. A test point is a point not on the boundary line of a linear inequality used to determine which part to shade. Now, graphing inequalities in two variables is similar to graphing a line. The graph of a linear inequality contains all the points on one side of the line, or may not include the points on the line. To graph your linear inequality, you're going to graph your boundary line. You will use a dashed line if your graph is a greater than or less than, which means the points on that boundary line are not part of the solution. You will use a solid line if it is greater than or equal to, or less than or equal to, which means the points on your boundary line are part of the solution. You'll choose a test point, solve the equation using the test point. If the test point makes a true statement, you shade where that test point is. If the test point makes a false statement, you shade on the opposite side of the boundary line where that test point is. Let's take a look. Let's say we have the following equation. Y is greater than 2x minus 3. First thing I'm going to do here is I'm going to pay attention to the fact that it's a dashed line. And I can look at this and I know that this right here tells me it's a dashed line. I tend to like to do that so that my brain doesn't have to erase things later because I didn't pay attention to this. This is already written in y equals form. Since it's written in y equals form, it's very easy to graph using slope-intercept form. So I will do that. So I start with my intercept, which is at -3. So my y-intercept is at -3. My slope is 2. Okay, my slope is going to be 2. My y-intercept is -3. So plot the point -3, apply your slope, which is up 2 to the right 1, up 2 to the right 1, up 2 to the right 1. This will be a dashed line, so I'm going to make this a dashed line. And it's in sort of English type color. Okay, so there's my dashed line. And now I need to figure out a test point. As a general rule, if your equation is written in y equals form, it has to be written in y equals form. If it's greater than, it should be above your boundary line. If it's less than, it should be below your boundary line. So since this is a greater than equation right here, it should be shaded above my boundary line. But I'm going to test the point anyway to ensure that I'm doing this correctly. The easiest point to test is 0, 0, so I'm going to test the point 0. Okay, so I have 0 is greater than or equal to 0 times 2 minus 3. So in other words, 0 is greater than -3, which is true. So I will shade where 0, 0 is. This is a true statement, shade where 0, 0 is. Which does follow the above the boundary line rule. So I'm going to shade where 0, 0 is. It's not going to be shaded here. Be careful when you shade. Don't shade so dark near your boundary line that you can't tell anymore if your boundary line is solid or dash. And once you've finished shading, of course, you need to label your equation. Y is greater than 2x minus 3. And you're done. And a linear inequality. Let's look at letter B. Now, letter B is not solved for y. I could solve it for y if I would like to. However, I happen to look at this and I know that 12 is divisible by 6 and 12 is divisible by 2. So it would be very easy to solve this using intercepts. So I'm going to use intercepts to solve this. Okay, so if x is 0, that means x goes away, and I have -2y is less than or equal to 12. 12 divided by -2 is -6. So there's that intercept. And if y equals 0, I have 6x is equal to 12, so 12 divided by 6 is 2. So my points are 0, -6, 0, 3, 4, 5, 6. It crosses the y-axis at -6, it crosses the x-axis at 2. This time I need a solid line. Okay, so I need a solid line here. And I think I'm going to still use the purplish type color. Greenish, purplish. Whoa, that was terrible. Let's undo that really fast. Alright. Now I'm going to tell myself I want to put my first. There we go. Now it's working out better. Alright, so I'm going to draw my line here. Whoa, that was not so good. Quickly, I can adjust. There we go. So there's my line. I need to use a test point. I have to use a test point here because it's not written in y equals form, so I cannot use the rule of, oh, it's less than, so it should be below. Okay? You look at this and say, oh, it's less than or equal to, but it's not written in y equals form, so I have to use a test point. So let's use the point 0, 0. So I have 0 minus 0 is less than or equal to 12. 0 is less than or equal to 12. That's true, so I'm going to shade where the 0 is, which in this case happens to be above the boundary line. Hence why you need to be very careful and not make assumptions that can get you into trouble. Remember, this is not written in y equals form, so you can't use the, oh, it's less than, so it's below thing, because it's actually greater than. Last but not least, whatever your equation, 6x minus 2y is less than or equal to 12. And you have your problem inequality. Now, you can also use inequalities to solve word problems. Okay, let's take a look at this particular problem here. It says, you put up a new shelf that is 1 foot wide to store some of your books and trophies. Each book takes up 1 inch and each trophy takes up 3 inches. What is the graph showing how many books and how many trophies will fit on the shelf? Notice it's not asking me to give a set of solutions, it's just asking me to graph it. So if I'm going to graph this, first thing I need to do is define some variables. Since I'm working with trophies and I'm working with books, I'm going to let x equal books and y equal trophies, and it doesn't matter which one is which. But I do know that if I did it the other way around, it wouldn't fit on my piece of graph paper there. That's the way I oriented my graph paper. I do know that each book takes up 1 inch and each trophy takes up 3 inches. And I only have a foot to work with, and a foot is the same as 12 inches. That's something to pay attention to. So the space for the space for the books plus the space for the trophy has got to be less than or equal to 12 inches. That's all I have is 12 inches. So if each book is 1 inch, 1 inch times the number of books that I have, plus each trophy is 3 inches, 3 inches times the number of trophies that I have, it's got to be less than or equal to 12 inches total. So there's my inequality. Very simple to solve by using intercepts because 12 is divisible by both 1 and 3. If x is 0, 12 divided by 3 is 4. If y is 0, 12 divided by 1 is 12. Right? Since we know that the x was books, remember of, and the y is trophies. Also, again, number of trophies. Okay. I'm dropping by 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Graph it. Number properly. Let's try that again. 1, 2, 3, there's 4, 5, 6, 7, 8, 9, 10, 11, 12. And obviously, 1, 2, 4. Okay, so 0, 4 is here, 12, 0 is here. Graph this line, which is kind of solid line. Solid line. Let's go in this color again. Use your ruler when you do this. It's very important to make sure that it's accurate. All right, since it's again not a set equal to y, I would test a point. If I'm going to test 0, 0, I will have 0 plus 0 is less than or equal to 12, which is true. 0 is less than or equal to 12, so I can shade below my line here. So anything within this green region is how many books and how many trophies will fit on my shelf. Knowing, however, you have to hit a coordinate point because you can't have half a trophy or a third of a book or something like that. So there you have it. You have your equation and you have your graph. Now, we can also solve absolute value absolute value inequalities, which means all you're going to do is apply one more rule than what you did with the last lesson. Last lesson, we learned how to graph absolute value graphs. We learned how to transform them. So now all we have to do is shape them when we're done. Same rules apply. You're going to graph your absolute value inequality graph just like you would before. And then the last thing you're going to do is test a point to determine whether or not it should be shaded inside the inequality, inside the absolute value or outside the absolute value. So let's take a look at this. What is the graph of y is less than or equal to the absolute value of x minus 2 plus 1? First thing I'm going to do is I'm going to figure out my vertex. Remember, vertex is h and k. So if this is h and this is k, h equals 2, k equals 1. So my vertex is 2, 1. Okay, so once I know what my vertex is, I look to see what the letter A is. A is 1 because there is no A. So I'm going to plot the point 2, 1. It is a solid line because it's not a less than or equal to, it's not a less than, it's a less than or equal to. The slope is 1, so I'm just going to go up 1 over 1, up 1 over 1, up 1 over 1, all the way through here. So here's my graph. Now I need to determine where I'm going to shade it. This is written in y equals form. It's less than, which means it should be below my vertex, which means on the outside of my graph. But I'm going to do a test point just to be sure. If I test it 0, 0, I will have 0 is less than or equal to the absolute value of 2 plus 1. Okay, so 0 is less than or equal to absolute value of negative 2 is 2, 2 plus 1 is 3, 0 is definitely less than or equal to 3. So that is true. So we're going to shade where 0, 0 is, which does happen to be outside of my graph, which is here. So we're going to shade outside my absolute value graph. And then the last thing we're going to do is we're going to make sure that we label my equation. Y is less than or equal to absolute value of x minus 2 plus 1. I do have it. Sometimes your graphs are not in y equals form. When they're not in y equals form, you must get them into y equals form. Right? And for example, letter B here is not in y equals form. You have 3 minus y is less than the absolute value of x plus 2. So the first thing I have to do is subtract it. So I now have negative y is less than the absolute value of x plus 2 minus 3. But I can't have a negative y, so I have to multiply the entire equation by a negative 1. Doing that gives me a positive y. But remember, when you multiply or divide by inequality by a negative number, your inequality symbol switches. To multiply the absolute value of the x plus 2, I have to put on the outside of the x plus 2. And then my negative 1, my negative 3 will change to a positive. So there's my equation now, written in y equals form. Y is greater than negative absolute value of x plus 2 plus 3. Okay. Which means my vertex now is negative 2, positive 3. Okay, and my slope is negative 1. So the first thing I'm going to do is I'm going to plot my vertex, negative 2, positive 3. My slope is negative 1 down to the right, 1 down to the right one, which means it's being reflected across the x-axis. Okay. And it's a dashed line. Dashed lines are pretty good. Or very straight for that matter. Right. Now, since it is written in y equals 1 now, I can use that to shade it. Shading should be above. So I'm going to shade above my graph here. And so it should be shading out here. And you can test a point to make sure you're right, and I'm positive it is because I already have. So I know that works. So there's my shading. So this is the equation of y is greater than negative absolute value of x plus 2 plus 3. Just be careful to apply all your rules of algebra correctly when you translate your equations. The last thing we have to be able to do is to write an inequality based on a graph. This graph's a little hard to read, do the best to understand it. First thing we need to do is figure out what our vertex is. It's the best thing to do first. My vertex. If I look at this, my vertex is right here, which looks like it's at the point 3, 0. Okay, so that gives me my h and k really easily. The next thing I need to do is find my slope. Okay, look at a point here, I look from this point here to this point here. Remember, they're counting by twos, so this is going up half a unit over a full unit, so it's going up 1, right 2. So my slope is 1/2, which means, okay, which means my h equals 3, k equals 0, and a equals 1/2. So now the last thing I need to do is see if it's a greater than or equal to, or less than or equal to, or greater than or less than. Since it's a dashed line, we know it's either going to be a greater than or less than. Since it's shaded below, okay, it's a dashed line below the boundary, okay, it has to be a less than. So that's everything I need to know to be able to write my equation. So now y, or you can put f of x, it doesn't matter, is less than 1/2 absolute value of x minus 3 plus 0. And you can leave the plus 0 off if you want and make it y is less than 1/2 absolute value of x minus 3. Either one is okay. They're both acceptable. And there's your equation. And that's solving two variable inequalities, or graphing two variable inequalities.